Okay, related rates. Okay, let me give you a problem, and through the problem, I'm going to explain to you what related rates is. Here we go. My pen. Example. A ladder (10-meter) long. Okay, rests against a vertical wall. Okay, that's the situation. If the bottom of the ladder slides away from the wall at a rate of 1 meters per second, how fast is the top of the ladder sliding down the wall when the bottom, almost done, of the ladder is 6 meters from the wall. Okay, that's the question. Yeah, are you okay with the question? So let me do a little picture here to see what's going on. Wall, floor, and ladder. Okay, so this is the ladder, this is the wall, this is the floor, and the ladder is 10-meter long. So that's given to me. This here is X, this distance, and this distance to the top of the wall, right? To where it is wall is Y. Okay, so what's given to me here? I understand that, okay, so listen carefully. The bottom of the ladder is sliding away here, sliding away from the wall. And obviously, as it slides away, right, the top of the ladder falls below. You see, it slides down, right? Makes sense. Situation like this. They want to know, they're giving you at what rate is this sliding. So the first rate they give you, the only rate they give you is it's sliding away, it slides away from the wall at 1 meter per second. This means that dx dt is 1 meter per second. Okay, so that's the first information that I understand from a rate here. Okay, it means the rate at which x is increasing over time is 1. Okay, that's a rate. Okay, so the first information that you get from the problem is it's a rate at which this distance is increasing. Okay, so dx dt is equal to 1. Is that okay?
Yes.
Okay, yeah. Now we're looking for what? We're looking for the rate, how fast is the top of the ladder sliding. So we're looking for dy dt. At what rate is y moving now? Okay, so we're looking for dy dt. That's what I'm looking for. But when, they tell you when, because apparently it's not sliding down at the same speed. It's not a constant speed. They tell you only when x is 6, right? From the bottom, when the bottom of the ladder, which is x, is 6 meters away from the wall. So when x is equal to 6. So I'll write this, when x is equal to 6, and that's what I'm looking for. Okay, so that's the first part on solving a related rate problem. Okay, so the first thing, of course, is to identify that we're dealing with a related rates problem, and that's pretty easy because they give you rates. They give you a rate inside. Okay, so chances are it's going to be a related rate problem. Second thing, identify the rate they give you. Identify the rate that you're looking for. Okay, given 1, looking for dy dt. Third thing, okay, is we need to find a relation between these two rates. That's why it's called related rates. Okay, it's called related rates because we're going to find a relation between these two rates. Okay, so let's go. Let's try to find a relation between these two rates. To do so, I need to find a relation first between x and y. Do you see a relation here that I could use? Yeah. Okay, so right away I know that x2 plus y2 is equal to 100. Okay, and if I'm looking for dx dt and dy dt, well, I'm just going to derive everything here. I'm going to find the derivative with respect to t of everything. Okay, so I'm assuming that x is a function of t, y is a function of t. So let's derive. The derivative of x2 is 2x times, right, chain rule, dx dt. Plus derivative of y2 is 2y times dy dt, and is equal to derivative of 100 is, of course, 0. Do you understand this? This is the tricky part where people forget the chain rule and they don't realize that it's a function of t. Do you understand this? Would you like me to repeat where I got this from?
Yes, please.
Okay, so I'm going to repeat this again. So I found a relation between x and y by using Pythagoras that I think everybody understood. Now, I need to find a relation between dx dt and dy dt. So very easy. I know that x changes with time. So x is a function of t, and y also changes with time because y is a function of t. Okay, so I'm going to write this here. Okay, so x really is equal to x of t. It's a function of t. And y also here is a function of t, is y of t. Okay, so if I derive x2 with respect to t, I'm going to get this. The derivative of x2 is 2x times the derivative of the inside, which is x prime, or dx dt. Okay, same thing for y. 2y times the derivative of y, which is dy dt. Is this okay?
Yeah.
Anybody?
So
Okay.
didn't we do this like with just one variable? The only difference is we're doing it with both variables.
Well, when we did it with one variable, the implicit differentiation, what we used to do is I used to consider x as my independent variable, and I would derive everything with respect to x. Okay, we had 2x plus 2y dy dt. There was none of this. Because, no, sorry, not dy dt. We said 2y times y prime, which was dy dx. We used to derive with respect to x. Now we're deriving with respect to t. So each of these I'm considering as a function of t, and not not as before, which was y as a function of x. That's why I wrote x is x of t, y is y of t. Before, we had x is x, and y is y of x. You understand? There's a difference between treating this as y depending on x, or treating this y as a function of t and x as a function of t. Okay, in related rates, there's an underlying variable or an underlying independent variable, which is in our case t. Okay, so everything here, all this system, which is moving, everything changes with t, with time. Anyways, we're going to do a few more. You're going to see you're going to get it. Any questions so far? Okay, so what do I have here? Well, dy dt is what I'm looking for. X, I know it's 6. Dx dt, I know it's 1. The only thing I'm missing is y. And if I have y, I could find dy dt, and I'm going to have my answer. How do I find y?
Pythagoras theorem.
Pythagoras, perfect. Right? I have, when x is 6, what's y? Well, it's very simple. I'm going to do my Pythagoras theorem here. This is 10, this is 6, so this has to be 8. There's no choice. Pythagoras. Okay, so y will be 8. That's it. I could find dy dt. So, okay, I could have divided everything by 2 to get rid of these 2's, but who cares? So I have 12 plus 16 dy dt is equal to 0, and so dy dt is equal to negative 12 over 16, which could be divided by 4, so negative 3 over 4. So negative 0.75 meters per second. This is how fast y is changing. Okay, so it makes sense. It's negative, means that every second it loses 3/4 of a meter. Loses, it's negative. It's getting smaller, of course, as x is getting bigger. That's it. We solved a related rate problem from beginning to end. Yeah, you understand it perfectly? Okay, let me give you, yes? Yes? All good, no question? Let me give you another question. Number 2. Okay, so I'm taking these examples from the book. Okay, so examples, so a water tank has the shape of an inverted circular cone. With a base radius of 2 meters and the height of 4 meters. Okay, so if water is being poured into the tank at a rate of 2 meter cubed per minute, find the rate at which the water level is rising. Okay, when the water is 3 meters deep. So here's the situation here. We have a cone inverted, so like this. The height of the cone (4 meters), and the radius at the base, so right here, the radius 2 meters. Putting water inside, and right, the water fills it, okay, fills it to a certain height. H, okay, and of course at this point the radius is r, I don't know. Okay, so depending on the height, you have a different radius. So what's given to me here? I know that water is being poured at a rate of 2 meter cubed per minute. So meter cubed is volume, minute is time. So the variation of volume over time is 2. Good? That's given to me. What are we looking for? Find the rate at which the water level is rising. So basically, at what rate is H increasing? So variation of height over time. What is that? And when? When the water is 3 meters deep, so when H is equal to 3, this is my problem. If you set up this, you already covered half, you have half the solution if you manage to set this up correctly. What is the rate that I have? What is the rate that I'm looking for? Question? Okay. So now I need a relation between volume and height. Well, what is the volume of a cone? So I'm interested in this little cone here. So the volume is, if you remember, 1/3 pi r squared times height. Okay. So this, I need a relation between volume and height. So now I have the radius, I have an extra variable here that I need to get rid of. How am I going to get rid of this variable?
We replace it
By what?
by 2.
By 2? Why 2?
I don't know, the radius is 2 meters.
No, the radius on top is 2 meters. The
Okay.
radius here is not 2 meters. It's definitely smaller, and it's not fixed at 2. It's whatever you're going to find, it's not fixed there. This
Is it
also
h over
changes.
2?
Sorry?
Is it h over 2? Because when h is 4, the radius is 2. So I would
Oh.
think that
Okay, good. You're talking
Radius
something.
would
Okay,
be h
good.
over 2.
Good. Okay, so if I draw sort of a cross section of my cone, okay. On top I have 2, and all this is 4. This is h. This is r. these two triangles, the big one and the small one, are similar because they have a common angle and 90 degrees here. So h over 4 is exactly equal to r over 2. Okay, so I'll write here, h over 4 is equal to r over 2, and therefore the radius is h over 2. Good, very good. Radius is h over 2, and I could replace now the radius here by h over 2, and I'm going to have a full relation between volume and height. So V will be 1/3 pi times r, which is h over 2 squared times h. That is V equals 1/3 pi h3 over 4. We'll move up a bit. And so V is equal to pi over 12 times h cubed. Good. I found a relation between V and h, and now I'll be able to find a relation between dV dt and dH dt, because that's what I'm looking for. Okay, let's go. Derivative of both sides with respect to t. So dV dt is equal to pi over 12 times 3h2 times dH dt. And that's it. H, they told us when it's 3. dV dt was given as 2. And now I could find what this is. Okay. So 9, so 2 is equal to 9 pi over 12 times dH dt. And if you solve for dH dt, I get 24, so 3/4, 8, so 24 over 9 divided by 3.
Are you sure it's are you sure it's 9?
What?
Are you sure it's 9?
Oh, no, you're right, It's 27, right?
Yeah.
I forgot the square. Yeah, 27, sorry. Thank you. Yeah, 27, so 27, so 24 over 27 divided by 3 is 8 over 9. So 8 over 9 pi, that's what I get. There you go, whatever that is. 8 divided by 9 divided by pi, so 0.28 meters per minute, I guess. That was my unit. And that's the rate at which the height is increasing. Okay, so obviously it doesn't increase at the same level depending on which height you are. Okay, if the water is being poured at a constant rate.